Na mihi nui kia koutou te hui hui e tēnei rā of the Environmental Science and Policy Committee. So welcome to this meeting of the Environmental Science Committee workshop. We'll just start off with a karakia. Paparongo aki au, tiritangi atu manu nei, ati mā tui. Tui karongo, tui kararu, tui kawaho, tui karoto. Tui ki te kauri tangata, karongo te pō, karongo ki o. Ki te whai o ki o marama. Thank you for that. So thank you all very much for coming along today for this workshop. First of all, we have Karen online. I think Karen Cook's online. Welcome, Karen. You're there. And we also have an apology from Edward Ellison, who's got a prior engagement with Matariki National Commitments up in Wanaka. Kia ora, Karen, not me. I don't have any other apologies. Is there any other apologies? So welcome to everybody who's here. We've got a pretty full team, and pretty much this workshop is a workshop that's sort of setting out all the background information that's feeding into the year plan, I believe. So we've got we have up the front Emily and Sarah. Yeah, Emily and Sarah. Yeah, and I see Tom's managed to drag himself out of his. Tom's been a little bit under the weather lately, but it's good to see you here, Tom. So we'll try and go easy on you. So I think pretty much we'll just let you guys take it away and guide us through the morning.
Cool. Thank you,
Sarah.
Kia ora koutou, everyone. So the purpose of this presentation is to. Oh, sorry, I just got to hit.
Just while we're getting ready, this workshop's to be recorded and will be made available later on.
Just while we're getting started, I'd just like to say that this meeting came about the learning from the land and water plan development. I think we got feedback that it would have been really nice to have a lot of science material up front prior to decision making on a couple of key things. Obviously that wasn't possible with the land and water plan time frames, and all that sort of stuff. But we are in a position to do that here and have heard you on that. And this is an attempt to put forward all of the evidential basis for decision making that comes with air plan activities in the future from a science perspective anyway. And you're keen to hear his feedback on the workshop afterwards and all that sort of stuff.
Thank you, Tom. Does everybody have the presentation on television?
Mm-hmm.
All good. Yeah. Will you take it away? Sure.
Okay, so the purpose of this presentation is to go over the science information that has formed a review of the regional air plan. I'm going to go over the background information and monitoring results, and then I'm going to hand over to Emily, who will discuss a piece of work she's undertaken for us, which was to analyse our monitoring data and calculate reductions necessary to meet guidelines and work out how effective different management options would be to meet these needs. So we have two key pieces of legislation for air quality in New Zealand. The first one is the RMA, and that says that regional councils must manage air quality. And the NESAQ, the National Environmental Standards for Air Quality 2004, provide the standards for doing this. And the key one that we're interested in is the 5 standards for ambient air quality pollutants. And these standards were developed and designed to provide a level of protection for human health. So these are the standards here. We have carbon monoxide, PM10, nitrogen dioxide, ozone, and sulfur dioxide, and they all have different averaging times, different limits, and different numbers of permissible exceedances in a 12-month period. And the final column, we also have ambient air quality guideline values, which those were developed a couple of years earlier. And so they still apply for something that's not covered by the NESAC. And so regional councils must monitor air quality where standards are likely to be breached. And early monitoring in the late 90s established that PM10 was the only pollutant of concern in Otago because it was the only one likely to breach the 24-hour limit. So air quality in any given place is a product of the emissions. So what has been emitted, how much, if it's combustion, what has been burnt and how much has been burnt. And the other thing is the meteorology and topography of the receiving environment. So these impact pollutant dispersion, and across Otago, both of these vary. And this is just showing some of the emission sources that are really common globally. We've got industry, windblown dust, and dust can be something that is impacted by human activity. So so anything that generates dust. Agricultural practices, the one that we're interested in is household energy, but there's also waste management and traffic. And this is just showing how a temperature inversion affects air quality. So in a normal situation, dispersion of pollutants is encouraged by the vertical mixing of the atmospheric layers. But under a temperature inversion, the pollution gets trapped because there's a warm air layer trapping the cold air below it, and it's not possible for those to mix. So our main pollutant concern is Otago is particulate matter, and the important thing to remember here is that chemically they can be made of anything, but so they're distinguished by size, and the larger particles can be dust, sea salt and pollen, sort of more natural sources, and the smaller particles come from incomplete combustion. And this has implications for health and for meeting standards and guidelines, which we'll talk about a bit later. Oh, sorry, I forgot to say, if there's any questions at any point, just say.
Yes, I'm just trying to find the presentation, but why didn't you refer to PM 2.5 in the first table?
There isn't a standard for it, although the proposed NESAC has included a new standard for PM 2.5 now.
Alexa?
The question I had was back a few slides, but late 90s monitoring of everything, I guess, in NO2 seems quite a long time ago. Microphone. Thanks, Kate. So that monitoring seems a long time ago. And is it still valid that PM is the only pollutant we need to worry about in Otago? How do we know that?
We have done some updated monitoring of some of those pollutants as well. But yeah, we're going to discuss a bit more about NO2 in future slides. So we'll
Thanks.
cover that then.
Sorry.
So Otago gazetted 22 airsheds, and they're kind of in groups of most degraded to least degraded. And what we've done is we've focused our monitoring on airsheds 1, 2, and 3. And so we have a monitoring site, at least one monitoring site at each of these groups. These are our sites here. We have 4 regulatory sites and 4 survey sites and a future survey site going in at Frankton hopefully in the next couple of weeks. The difference between these 2 types of site is mostly instrumentation. There are NESAC approved monitoring methods, and we only have these at 4 of our sites. But those are the sites that are the representative airshed sites, so they've been planned that way. Our survey sites, the instrumentation isn't able to be compared to NESAC, but it's still good quality data for like other types of analysis. And these have been sort of installed in a more ad hoc way into some of our airsheds that we just wanted to know more information about. And for both types of site, we are undergoing an upgrade process, and we're transitioning from our older like instruments that were installed 20 years ago. They're coming to its end of life, so we're replacing them with newer instruments that show a different type of technology.
So,
Yeah.
so why have we chosen Frankton when it's in a yellow, an airshed 4 zone?
Well, because we don't have any monitoring in airshed 4 yet, and so it was just an idea to sort of cover those areas because we didn't know that much about them.
Right, yet we're not doing, well, we might be, but we're not doing in other areas that have got you know, one, 2 or 3, for instance, or Henri would be the first one to look at. But AM monitoring, because you've gone to a good quality, a supposed good quality air shed, and but not monitoring the more effective ones.
Yeah, those decisions were made in 2018, and I'm not too sure what drove that, but I think just the growth of that part of the country was one of the drivers for installing something there. For all of the other air sheds, we're undergoing a process of investigation to see where else we should be monitoring.
So, part of that exercise is determining whether or not that particular area is in an appropriate issue classification at the moment. So while it sits in that, and that's area 4. Well, it sits in that issue classification at the moment. There's a bit of anecdotal evidence that it perhaps isn't in the right issue. And so the monitoring will look at confirming where we are.
So I'm going to talk
I
a bit
don't know
about
which
our
ones, you know.
SLE monitoring results now. These are our annual averages compared to the annual guidelines. And we can see over time, things have been trending downwards roughly at most sites, and we're mostly compliant now with the ambient air quality guideline. And the new World Health Organization guideline is a little bit stricter, so we're sometimes meeting those as well. There is a bit of a spike at the end of the data set, and that is our Dunedin site, which had a building development happening for all of 2022. And these are our number of exceedances of the NESAC, and they are also improving over the years at least Arrowtown and Central Dunedin. For Alexandra and Mosgiel, it's not a super clear trend, but still, this is where we're at. We still have exceedances of the NESAC.
Sarah, I just going to clarify, that's the number of days it exceeds, not how much it's over.
Yeah, but that's the number of days it exceeds.
Excuse me, just a question on this. I've got the same chart here, and underneath this, the wee asterisk says data was not included during winter months. So the winter months, I would imagine, would be the most indicative months of air pollution.
So that's just for 2012 for the Mosgiel site where it's got an A.
Oh,
Yeah, there was just something wrong.
All
with
right,
it.
okay, thanks for that.
Elliot's got a question.
I was just wondering about the Dunedin side. So are the ones for these regulatory results are the only ones with those big blue boxes. So am I correct in that the one for Dunedin is like off right near the Greeks factory?
Yeah.
And I was just wondering because the map earlier had Central, South and North Dunedin as separate sites.
Yeah.
Would that spot not be considered North Dunedin?
Well, we have a North Dunedin airshed that is basically Northeast Valley, and so we
Right,
call
okay,
the other
so-
site Central Dunedin.
Yeah. And then also is that does the Greeks factory live with that data at all?
So far it's been okay. Basically the site's always been in that vicinity, and there's a lot of other discharges going on as well. But yeah, that is something that we can look at in the future.
It's correct though that you need to put your site in the worst place in that airshed as well. So if it messes with the site, I guess that's it might be potentially the worst site, but also, just from the past, we had a lot of discussion about whether salt spray or just because we're a coastal city as well. And then there was dust from construction. There's all sorts of things, aren't there, potentially, but it has to be in the worst site, is my understanding.
Oh, right.
I wonder, we're just going through some of these overheads pretty quick. Can we go back to the graph, please? I mean, from 2020 to 23, I find that sort of quite interesting. So, sorry, can you please remind me what's AAQG?
That's the ambient air quality guidelines, so that applies when there's no NESA.
Okay. But I think what you're saying is that there is a period of time that Dunedin, and believe it or not, Alexandra are meeting World Health Organization standards. Yeah. And I'm a little bit shocked by that. I mean, the Alexandra one, and I don't mean to.
Would you rather we don't?
Yeah.
No, but it's just in terms of the rhetoric at the table, because I've always perceived Alexandra had bad equality was actually meeting World Health Organization standards,
Very
Which
high
is a
bar,
good
very
thing.
high
It's
bar.
a
in
great
Alexandra.
thing. We've rapidly changed.
Yeah,
No, guys, just one at a time.
yeah, but it's interesting that, and then the whole graph sort of reverses, then Dunedin's meeting the World Health Organization, then it doesn't actually meet the AAQG, and then and like everything's bad and some of them are good at some time.
The Alexandra site was moved, so what you're seeing there is actually a better part of the issue than where it used to be.
Yeah.
So if we were looking at that old data, it wouldn't be meeting that, but it's just.
So going back
consequence of
to
moving the
Councillor
site.
Robinson's point, is it in the right place?
Yeah, we discussed this in our last meeting about what we can do about that, but yeah, it's not technically in the right place in the issue.
Okay. And tell Gary.
Thanks. Thanks, got a question?
Data is the data, and I get that, but there's also some other changes, aren't there, that we possibly aren't measuring. And as someone who's lived in Central Otago now 32 years, that we get a lot less fogs. And every year can be quite different in that. So that will have some bearing on this potentially, and also how often people are fires. But the data I'd be really interested to see in line with this is how many cents for new fires and compliant fires have gone in that time, because that surely would have also quite a substantial effect. Even the old site at the school would have had an effect, wouldn't it, if they changed their fueling system?
I'm gonna let Emily answer that one.
Yeah, those sorts of variables feed into the work that I do.
Yeah.
And including the impact of year-to-year variability in meteorology.
Mhm.
If I don't answer the question, or if you've still got a question after I've talked about that, please come back to it and I can address it more fully.
I'm not sure that you can even answer it, does, I mean, but as long as it is a factor, and then.
It is a factor, and we do have ways of taking it into account. Yeah.
Thank you.
I was just going to quickly mention just that discussion about the Alexandra site. It's challenging to get sites. People don't really want to have them. Sarah took a long time to get the Franklin site up and running. There's lease requirements. There's all sorts of things. So potentially people think they look a little bit ugly. We're doing some work on making them look a bit nicer, but it is hard to find our site. And so sometimes optimally you want the worst site, but sometimes it's our site. We'll give you some data. So just a factor in terms of what we do. And the other factor is we only have one BM resource dedicated full-time to air quality. And so their workload is maximised at the moment. And we can't add more sites without more resource to monitor him. He's got a massive area, as you can imagine. He does, he's got a little bit of support along the coast, but otherwise he does the rest of Otago.
Thanks, Sarah.
So this graph here is just providing some context, some national context for where we sit compared to the other sites nationally. And this data is a few years old now, but any iteration of this graph, you'll see that we tend to be among the worst of the issues in terms of number of exceedances. And so this is just some extra data to demonstrate how we know that these are from home heating emissions. So our data is really highly seasonal. The middle plot there shows that winter is the middle of the year, and that's when we're getting the highest concentrations for all of our sites. Except for the blue line, that's Central Dunedin, and that's doing its own thing. And also the plot on the left is showing the morning peak and the evening peaks that are typical of home heating emissions. And this is just to demonstrate that wherever we measure, we find these patterns everywhere except for Central Dunedin because the sources are different. Particulate matter varies spatially between airsheds and within airsheds, and these are plots you guys have seen recently. And concentrations are correlated to low temperatures and low wind speeds. These are our long-term trend results from the recent, from this year's analysis. And basically everything is mostly improving, but it's improving at really slow annual rates of change. So the fastest rate of change is Arrowtown at just over 6%, but then we get down to Mossville and Cromwell, which are only 1.8% per year. And so, and as you've seen, our NSAC is still not being met. And I've just highlighted Alexandra there because we came up with a degrading trend for that site. However, we still need a few more years of data to confirm this because it was only 7 years, and that's not a long time for a long-term trend. So I've just talked a lot about the concentration.
Sorry.
We pause at each slide.
Yeah, pause after Alexandra for each one. That's a bit harsh for Alexandra though, isn't it? That's a big red degrading banner. When really it's only a number of years. Fair enough, the site, there's a massive difference between the sites. And I'm just looking at on GIS where 65 Bentry Street is, which is right beside the new Countdown, versus right down in the centre of town. And so, but the numbers are so substantially different between what was being read down there versus up at Countdown. So, you know, with the exceedances or the variances, there's no real clear trend. It's sort of a bit of a hump, and then it's back to from 2 to sort of 3 with a lift to 6. Would it be a little bit unfair to be branding that as degrading at this stage?
It's just what we got, but it does come with that caveat that it wasn't a lot of data. Yeah, so it was still it's
just as a counsellor for me, like I have people who come to me talking about air quality, and they've moved to Alexandra with health issues and have raised it several times. So when this type of thing comes through, it just reinforces their position that air quality is bad and it's there as degrading, and what am I doing about it?
well. We looked at the previous, because you know how I said the site has been moved, there was still 10 years worth of data at the previous site as well. That wasn't really trending anywhere. So to me, that suggests that in general, Alexandra just isn't improving and isn't degrading. We found these degrading trends that didn't look like they were driven by home heating. They look more like they were driven by other seasons, because you can sort of analyze the trends by season. So yeah, if it helps, it doesn't seem like that degrading trend is due to home heating.
I'll just add that Alexandra is a really tricky site for a number of reasons. One, we changed sites. We lost access to what was a long-term site. We've had to create a new one. From the work we've done today, looks like that new one might not be ideally positioned. We've just got to a place where we've got enough data to be able to start to describe our trend, but that trend is, as Sarah said, uncertain. The best picture what we can say is, you know, with confidence for all of the other sites, is that they have a trend, that they're moving in the right direction. With a low level of confidence, we can say that Alexandra seems to have more factors than just home heating that are influencing the trend. That the trend doesn't appear to be sustainably moving in one direction or another, i.e. it's flat. And therefore, if you're thinking about this from an air plan perspective, it might be a site to focus some attention for the planning process.
So if we arrived at degrading is probably a little bit unfair.
Yeah, degrading is probably a little bit unfair, but improving is definitely not the case as well.
And I think all of our messaging around Alexandra has been caveated with the site's been moved, it's only a short-term data set. We're not making, general, decisions based on that, and we need to get some more data, but I think the reality is, as Tom said, it's not, in Sarah, it's not getting better either, so, but we do caveat all that information around Alex.
Yeah, but we can't definitively say it's getting worse either. We are using data that is.
We just need more data.
all over the place. And in the interim, there are people who are doing their best, making investments, making changes to their home heating. We're hopefully improving burning practice in homes. Yeah, okay, I'll leave it at that. Thank you.
And some of Emily's slides will cover some of that stuff as well, I think.
Just from myself on that one, Tom, I'm out of tune, but is there a way that when you're doing your science reports, that it can be noted on there that, instead of having just a big red degrading sign, have it noted somehow saying that although the trend says degrading, it may be due to LSE stuff. It's in the next paper that we're doing.
That's a fair point. I think the reason the box is highlighted is because we're going to talk to it rather than slapping some words on the slide. But the paper that you'll see this afternoon and is in your reading material as well does highlight that there's a range of reasons for uncertainty and that there are some challenges with that site. And we're certainly aware of it and certainly convey that to any decision makers and any people working on future policy and all that sort of stuff as well.
I've got Elliot and then Kevin.
Just on that data, I was just gonna ask if we were to find a new site, a better site in Alexandra, would we leave the old site up for at least a while and get some overlap so that we can sort of try and map those trends onto one another relatively?
Yeah, ideally that's what you would do. You need 12 months for that. Unfortunately, we couldn't do that when we moved it the first time because it was like a sale of property. So yeah.
So looking at Alexandra, has the movement been sufficient to take it out of from one airshed rating to another? So you've got the 1, 2, 3, and 4. So Alex was in whatever it is. So has the movement been sufficient to take it out of the degraded?
It's already an airshed 1 and it's still degraded.
Yeah. So it's actually, no matter what we call it, it needs work.
Yeah, that's right.
That's right.
Here is there's still days, significant numbers of days of exceedance in that airshed, and that there's not a trend in any direction, i.e. you can expect those days of exceedance to continue, and the associated risks to continue with it.
Sarah, it might just be helpful to articulate what the NESAC requirements are in terms of whether or not you're a polluted airshed, so the number of days you can exceed.
You're a polluted airshed if you exceed more than once in a 12-month period. So it's just more than one exceedance is when you start breaching the NESAC. So Alexandra, even though this new site is still exceeding about 4 times a year.
I think we're good to go again. Thanks.
Cool. So this is just a slide on the emissions inventory. So this is another type of data that we can collect to get information about our airsheds. Emissions inventories take stock of the emissions within an airshed using information from census information, home heating methods, resource consents, and NZTA data. And they help us identify the main sources, and if they're done periodically, we can see the trends over time, and that's useful for helping interpret our data trends. And the other thing they show is relative contributions that different sources have to emissions. Oftentimes, older burners are contributing disproportionate amounts of emissions compared to the actual numbers there are of those burners. All right, so we're going to go over air quality and health now. There's been quite a few updates to the health research around impacts of air quality on health. Firstly, in 2021, the World Health Organization released some new guidelines, and they were much more stricter than the previous 2005 guidelines. And basically most air pollutants are more dangerous than previously thought. And the left infographic has the 24-hour guidelines compared to the 2005 ones, and the right infographic is showing the annual guidelines. So in both cases, PM 2.5 and PM 10 have more stricter guidelines, and I just want to draw your attention to the nitrogen dioxide one as well. That on the 24-hour average side, that's a limit of 25 micrograms per cubic meter, and there didn't used to be a limit at all. And so that is something that people are, well, the councils are thinking about trying to monitor more for now. And the
Oh,
other,
yeah.
sorry.
Sorry, can I just ask a question, because it's probably me, a couple of slides ago, the one where you've got the your emissions, and it's got it split down into open fire, multi-fuel burner, wood burner, et cetera, et cetera. So my question is, do we have the technology to be able to measure from the air what type of fire is being used? Is that what they're saying?
It's not a top-down type assessment, it's a bottom-up. So we do surveying to of householders to understand what their heating methods are and how often they're using them. So it's a sort of bottom-up approach.
So you're aligning it to the number of those types of fires in the area.
Yes, and then we'll have something called an emission factor, which is the amount of emissions that come out per kilogram of fuel that are burned for the different appliance types.
Yeah, no, thank you for that. I thought that was pretty sharp being able to measure it in the year.
Can I just follow that up with, I noticed there's a pellet fire, it might only be one of them perhaps in Mosgiel. Is that a better way of heating than a wood burn or multi-fuel burn?
Better is quite a loose sort of term in terms of
emissions.
In terms of emissions, the pellet fires are probably more equivalent to what is called a ultra low emission burner. So the very best sort of type of burner is probably equivalent. The pellet fires have an advantage in that there's limited or less scope for operation of them. So they tend to have a much more controlled sort of fuel loading and combustion process, yeah. But don't tend to be overly popular because the fuel cost is quite high.
At the end of the day, depending on the way you burn your fire, the type of fire you have, the actual pollutant is the same pollutant. Well, yeah. It is.
Are you asking, are we talking about the same contaminant? Is that the question?
Basically, yeah,
Yes, the main contaminants that we're focusing on are particulate. There might be slight variations in some of those and lesser or contaminants that we're not quite as concerned about. But in terms of particular, that's what we're focusing on, yeah.
How you burn your fire will determine the amount of particulate.
It's like your size of the.
And what you burn.
Yes, absolutely, and all those things come into it, and I'll probably talk a little bit to some of that and some of the management measures that we are going to discuss.
Thank you. Sorry for going backwards.
We are moving quite quickly because we've got quite a lot of slides and not a lot of time, so do stop us if we are going too fast.
Don't slow down.
One of the other health updates was the release of the health and air pollution in New Zealand model, and the important thing about this is that they modelled the health impacts for PM 2.5 and NO2. Previous versions of this model only used PM 10. So this is one of the first things that was alerting us to the dangers of NO2 on like a national level. And so these are the main findings here. They have number of cases per year in terms of premature deaths, hospitalizations, and restricted activity days, asthma prevalence. And they also have that in terms of the social costs that it's costing New Zealand. And one of the other things they found when they back projected the model, they found that PM 2.5 has been improving. And they attributed that to the improvements made by councils in terms of replacing wood burners. But NO2 has been getting worse over the last, between 2006 and 16. And this is because there are more cars on the road. These are the stats for Otago. So I got these from this website, which is Environmental Health Intelligence New Zealand, and they have all the infographics and everything you could want down to a territorial authority level. So we see in Otago, we've got pretty much equal numbers of premature deaths due to each of these pollutants. And the other health study that is recent from 2022, Southern DHB did a study on, and they found that as PM10 concentrations increase, the likelihood of GP visits for acute respiratory infection also increase. So there's a direct link between concentrations and a health impact there.
Cyril, just on your health one, so why are we using a 2016, which is 8 years old? Why?
I can answer that.
Yeah.
So the HAPPEN study is a study that's carried out throughout New Zealand, and it's updated typically every 5 years. So 2016 was the last one that's done. It can't be updated in real time because it requires the input of baseline health statistics, which takes some time to compile at the census area unit, or the sort of small spatial area that's required to have that data available. So it's not, it's not something that can be assessed in real time, and it's probably due to be updated again because 2016 obviously is more than 5 years ago now.
Yeah.
It's quite a resource intensive study to update. So I'm not sure when the next one is scheduled, but while the data, the PM10 and PM2.5 data in it obviously could be updated, it does have a tool available for it, so that you could go in and put current concentrations in, and it would give you updated assessments of those health endpoints for your towns or for the region as a whole. So it is an interactive tool, but the next update, you can't update the mortality statistics with baseline health data until that's available, and that has to be done by the people that develop it.
Right, so it's taken them for 3 years now. Updated.
This study was only published in 2021, so even though it's a 2016 baseline, so that's the baseline year that's used in it, but it's a 2021 study.
We got a question from Helen.
Thanks. But I understand, as you said, that HAPPEN study breaks things down by territorial authority, and I understand the pattern for Dunedin actually is quite different from the other parts of Otago. And I just thinking about the implication, well, your comment on the implications of that, where Dunedin, those social costs of health effects, the majority is the nitrogen dioxide, whereas elsewhere it's a particulate matter. You get some comments on the implications of that?
I don't know that there's anything further that I've got to add to that. I guess probably the only comment that I would make about the NO2 is that I have been looking at it. The main source of NO2 is motor vehicles, and I have been looking recently at motor vehicle emissions projections and looking at impacts of national policy on NO2, and there is over the next sort of 26 to 30 years, it is projected to decrease significantly by about 90%. So for motor vehicles on an individual vehicle basis. So that would likely offset any increases, would easily offset any increases in VKT, and you could expect, in the absence of having to do anything, a decrease in NO2.
And since 2016, I guess we've also seen the increase in the number of diesel vehicles, which are the very worst, I understand. So in the meantime, things are probably going the wrong way.
Yeah, and there are other pressures on older vehicles as well, like the increase in the proportion of older vehicles in the vehicle fleet also contributes negatively. But on the converse side, an increase in electric vehicles and those sorts of things, which are factored into the model that I was talking about, has an improving effect in the long term.
But Brian, you have a question?
Yeah, just I'm trying to understand that. So you're saying that the NO2 goes down over time, but it's not necessarily through a reduction in vehicles, it's better quality of vehicles. Is that what you?
Yes, that's correct. There's been emission standards for vehicles that have been introduced by the government sort of progressively, and that has an impact on the tailpipe emissions of NO2 over time.
Yeah. Actually, a silly question is the premature deaths. We've got 99 PM2.5 and 101. Is it the same? What about the same person dying from? Is it potentially it's the same person?
The effects are independent, so it's a two pollutant model, so it's looking at independent effects.
No, fair enough.
Yeah, I don't think it's the same.
Generally,
person.
any time.
Right. I don't think we can.
Yeah,
do
I
that.
saw the title was big, but I got yeah. fair enough.
Like we can carry on, I think. Here.
All right, so what does all this mean for our standards and guidelines? In 2020, the NESAC proposed a standard for PM2.5, but then the year after that, the World Health Organization released their stricter guidelines. So we haven't heard yet what the impact of that will be on the future NESAC. But it's important to note that the NESAC for PM2.5 is half the limits for what it is for PM10. And that has implications for if we look at a graph of our data, this is our Arrowtown data, and we can see that in winter, pretty much all of the PM10 is PM2.5. And so the top line is just showing how many number of exceedances we have for PM10 NESAC, it's just 12. But then when you're like comparing it to a line that's 25, there becomes 30 exceedances for PM2.5. And so this just means that we're going to see more frequent number of exceedances for PM2.5, no matter what the NESAC ends up being, or no matter what guideline we're comparing to. But we're not alone in this. A lot of councils are sort of saying that they're going to be seeing exceedances where they didn't have them before. We have some knowledge gaps. Oh, sorry.
So is there anything with most of this EDS stuff's all getting changed? Is there any movement from the government, any indication that those numbers may change?
I haven't heard anything, have you? No.
I haven't heard any values, but I do understand some pieces of work are being carried out that would be moving towards what that standard would look like.
Yeah.
I just think for context, the NESAQ was meant to come out, the revised one in 2019, I think. And there's now one person at MFE working on equality.
Can I just, this is interesting more for what's below it, because there will still be exceedances in the summer months or the spring, potentially on the who, if that was done. Our job is to effect change if there are discharges above any exceedance level, whatever that be. At that time of the year, I mean, how do you know in some of these other months what those exceedances are caused by, because they won't be us? And what are the tools that we would have to actually influence them?
Yeah. So households are still using their home heating methods quite often well into October. And so with the emission inventory, we tend to focus on the winter months, but we know that people are still burning well into, those September, October months. So it's very rare to get an exceedance outside of the winter burning months, but on occasion you might get an odd source that is contributing.
How much of this is affected by burn-offs, which are done for a number of reasons? Does that ever show up? Because
I don't. I've done a bit of work on contribution of outdoor burning to particulate concentrations in a few locations. It's very, very difficult to ascertain. Occasionally you can see the data, you can normally visually see a burn off, but everything has to align pretty well for it to actually show something solid at a monitoring site. You can never actually look at your concentrations and go, well, I know it's this because of I know it's X because of Y. All you get is a concentration. And for the burn off too, you've got to get your wind direction exactly right and that sort of thing. So to answer your question, I guess if I'm loosely interpreting your question to sort of be about that outdoor burning contribution, I think that it is actually can be quite significant in places because you can visually see that, but to actually break it down by data is not really possible.
So it's actually not so, yeah, I probably worded my question, my question was bad. Those one-off events, how dangerous are they if you inhale that on a one-off basis as opposed to something that you're getting constantly?
I might just talk to that a little bit later. Yeah. Okay.
We still have some knowledge gaps, and there's a couple of things that would be really great to do in future, such as source apportionment, which identifies it does an elemental analysis of the PM, and so that identifies the source of emissions. That would be quite useful in our more complex issues, and especially Alexandra at this point. And another option is meteorological analysis, and that's to remove the meteorology, like the influence of meteorology on the data, so that you can see only hopefully what management options that we've sort of done to improve those concentrations. And I've put down other pollutants for future monitoring, but both of these are in the LTP, and that is NO2 and black carbon. And we're currently already monitoring black carbon. I'm just going to quickly go over some of our air quality management. And so our 22 issues were regrouped into air zones for the purposes of management, just to make it easier. And there are rules for wood burners and the types of ones we can install. So for air zone 2, which is pretty much everything except for the worst 4 air sheds, we can install burners that are less than 1.5 grams per kilogram, which is actually the MFE standard. And we have a more stricter rule for air zone 1, which is less than 0.7 grams per kilogram. And ORC implemented an incentive, a clean air subsidy to help transition the residents from old burners to better, more compliant burners. And we replaced over 1,200 appliances, and that accounted for 60% of the burner installations in those towns. So it's quite a good driver to getting those replacements done, but also people were having to replace them of their own accord as well. And this is probably too much detail, but the Southern DHB assessed the uptake of our subsidies along with the Eco Warmer Kiwi Home subsidies, because they were sort of run in conjunction for a few years. And they found that our program was quite successful because it was so targeted. So the Air Zone 1 and Milton, where the subsidy was available, was only those air sheds make up 8% of occupied dwellings in Otago. And so it's quite targeted, and about between 20 and 30% of those dwellings had a burner replacement in the years that we were running the program, which is quite good. And finally, I've made it to the end of my slides. I'll just hand over to Emily now, unless anyone else has got any questions.
Can I just get back to that slide you just found? So that's been a good uptake, and I presume that's around your cozy home stuff as well. That's all that's been happening. But so have we an understanding of the number of houses that still have the wrong type of burner in place?
Yeah, we have a bit of an understanding through the emission inventories and through looking at the building consents data for replacing burners. And so yeah, there's some numbers there, but what we don't have is information on the new homes that have been built and whether they have burners. So it's a little bit difficult.
Thank you, Sarah. That was very good background information we've had. It's all pretty new to a lot of us, to be fair, so it's quite find it really interesting, so we're continuing.
I think Emily's got a response to.
Oh,
Oh,
sorry.
no, that's all good. No, I'll deal with it.
So I was just going to say, that information should be easy to get. You just go to the district council and say how many permits have you had for new burners over the last period of time? And
Yeah.
where were they?
Yeah, so it is kind of information that's integrated into the mission inventories, which is part of the work that I do.
Yeah.
And so we do have, we have, there's a number of different ways we have of looking at what types of burners or what types of heating are going into new dwellings, and that's factored into the work that I'm doing and the mission inventory work as well. So it is something that we are accounting for.
And what about the impact of coal, particularly in Milton?
Yeah, we account for that as well in those surveys, and also we have other information on that as well. So yeah.
Can you talk to that?
Well, I can talk to it. Yes, I can. Yeah, I mean, but if you have a specific question about it, then I can.
How many houses burn coal? How much of a problem is it?
I'd have to go back to I can probably get you that if we get a wee break. I've got that on my laptop. But it wouldn't be for like this year. It would be for the last year that assessment would have been done.
I don't think we should lose that issue.
Yeah.
Okay.
And also I'm pretty sure in the report that I've done, there is a trend in that over time. So you can see by heating method, wood, electricity, coal use, and you can see for each area what the relative proportion of it is and how it's trended over time. But that particular information is from the census. So the last year that it is updated to is 2018. But what it shows in most areas is that coal has decreased significantly over that time.
So going back to my original question, so, you know, if we've got to make some governance decisions on how we help resolve the problems or help Otago resolve the problems, it'll be really important to know the size of that problem, because so therefore, if, you know, we actually do need to know, or somehow need to know, the amount of fires that are still types of fires, so we can then work a scheme around, understand the cost of fixing that problem and understand how we can actually do that.
And that information is part of the work that I do, so we can, you know, tease out that from the projections models and the baseline inventory data and other data that I have will give an indication. It won't be exact, but it'll be enough to be able to formulate the size of the resource needed.
Right, and so have you been working with Cozy Homes along to get that sort of data as well? Because I understood that they were actually, that was one question as a funder of Cozy Homes back some years ago that we were asking them to achieve as well.
Yeah, we did used to work with them. We haven't funded them for a while now, so we haven't been able to really ask them to do stuff for us.
Yeah, I'm not talking about us funding them, but yeah, that's right. Yeah. Good.
Can I just suggest there's a couple of outstanding questions that we'll attempt to answer in the next section of the presentation. And 5 minutes would be really useful for us to just quickly rally and make sure those questions will get answered. So if we could take it for 5 minutes.
If you want to do that, so we'll just adjourn till 10 o'clock. Eh?
Thank you.
Good on you. Okay, so thank you very much. Just re-adjourn the meeting. We'll pass over to Tom.
And I'll immediately pass over to Emily.
Sweet.
Is there someone I can pass over to? So Thank you. I'm here today really just to talk about this report that I've done for your council, which is about air quality management in Otago. There's three main aspects that I'm going to cover in this, but I have done a lot of work in air quality management in a lot of urban areas of New Zealand, and I've assisted a lot of councils with the science towards helping them understand what policy options might achieve. And it is a scientific evaluation, and if you do have any questions that might extend beyond the scope of what's here, I'm more than happy to assist as well as I can. But the key components of this report, or what I want to talk to you about today, is first of all the guideline review or the health impact assessment, and then looking at what reductions or the magnitude of improvement that is required in these areas to achieve different targets, and then finally what management options would achieve and how much reductions could be expected to occur with different approaches. Sorry, my voice just got a wee bit croaky, so I just have a wee drink. I'd like to blame that, but I don't think so. All right, so starting off with the health literature review. So as Sarah had talked about, the World Health Organization have in 2021 revised their ambient air quality standards, including for PM10 and in particular PM2.5. You will be most familiar with managing air quality, as most councils are in New Zealand, relative to a PM10 national environmental standard, and it's a 24-hour average. When that standard was set, which was early 2000s, there was a body of evidence of health impact that was probably quite young. It was 10 to 15 years sort of young, so it was in the early sort of stages. And since then, there have been a lot of resources and a lot greater understanding about many aspects of the health impacts of air quality. And that understanding is sort of culminated in World Health Organization 2021 guidelines, which and a lot of the background documentation to those, which really tell us that it is the chronic or the long-term exposures to concentrations of PM2.5, which are the most significant from a health viewpoint. Now, just to quickly sidetrack not sidetrack because it's a part of this, but to answer the question about the relativity of the short-term exposure versus the long-term exposure, the body of evidence that is available now still indicates that short-term exposures have a health impact. There is an acute effect that we can observe in health endpoints that occurs, a day to 3 days after a high pollution event. But when we quantify the magnitude of that impact versus the magnitude of an impact of prolonged exposure, we can see an order of magnitude, a factor of 10 difference between the two. So when you have a chronic exposure, it's going to, for example, for the premature mortality health endpoint, it's 10 times higher for a chronic exposure or a long-term exposure than it is for a short-term exposure. So whilst we know those short-term exposures do have an impact, what we really want to do to improve the health the most is to focus on reducing those annual chronic exposures. But both go hand in hand, and I think it would be very unlikely that there would be a guideline, for example, in the review of the NESAC, that they would have a guideline for an annual without a short-term guideline as well, because a short-term guideline is indicative of a health impact, and there are situations, for example, if you were looking at managing industry, where you would want to manage towards a shorter term standard as well. So both are relevant. But in terms of managing and where the energy should focus on in terms of developing management measures or targeting improvements, things that are looking at annual averages would be my recommendation based on the health literature review. And then also just noting that, as Sarah mentioned, the World Health Organization guidelines and in addition the HAPPEN study both are indicating that there is increasing concern with NO2. I would also just like to put that in context of the situation that I referred to earlier, where we were 15 years ago, we were at this early stage with PM10 in particulate. The evidence on NO2 is more in the early stage relative to than the evidence with the PM10 and PM2.5, which is classified by WHO as strong. So PM2.5 and PM10 are strong. We know a lot about these now, and we know what they're doing and how they're doing it. There's still more to learn, but we have a really strong scientific understanding. With the NO2, there are still some inconsistencies in the health literature. There's still variability that's not well understood. And so whilst we will likely, and our World Health Organization have implemented a guideline, which means that there's enough to know that it is increasing concern, there could still be changes in our understanding with time, would be my interpretation. In terms of the guideline derivation, you've had information already that the World Health Organization has set the standard at 5 for annual PM2.5, and that the proposed NESAC, which came out before this, had a higher level, which was 10. That proposed NESAC for PM2.5 that was set at 10 was based on the World Health Organization 2005 guideline. So it was based on quite an outdated guideline. That said, we don't know what the revised NESAC for PM2.5 will be, whether it will come out at 5 or whether it might be some other sort of form. We don't know what that is. We don't know what that is yet, but the indications is that it's going to be a downward guideline. And one of the things that I looked at, so I talked to you about the relativity of the daily and the annual in terms of health impact. One of the things that I'm very aware of with the towns that you have here and also in many other parts of New Zealand is that we already had a lot of signals, and Sarah showed it in the graph before, that it's actually really hard to meet that daily guideline. And so I wanted to get a little bit of an understanding about what the basis of the World Health Organization guideline around that level was, that 15 that they had set for that daily PM2.5 guideline. And when I did the reading around that, they highlight in there that the annual average is the main variable or the main guideline that you want to achieve. But rather than set a daily guideline based on effects around daily concentrations, their approach to setting the whole guideline has been to set an annual guideline and then to use a distribution of data to work out what that would equate to on a daily basis. And so they've used studies from over 300 databases to work out what this average distribution would be. But in New Zealand, we're actually quite different in terms of how our air quality is relative to overseas. And so we have a much steeper distribution of data. And so what that means is that what their level might be, the equivalent for us, where that guideline would actually be a lot higher, because we have a much steeper, we have much higher concentrations relative to our mean. So the ratio between our average concentrations and our higher concentrations is greater. And so effectively, what that means is that the standard that they have set, or the WHO guideline, the basis for it is a little bit disjointed, or it's a little bit misaligned to how things are in many towns in New Zealand. And in particular, when I look at it for your towns, the ratio that they've set it on, you can have a look down on this graph here. It's the third column of data across, the one with the arrow on it. This is the ratio of the annual concentration to that sort of peak. It's based on the 99th percentile, but it's sort of that peak concentration or the very high concentration. It's not quite the maximum. And theirs is based on 3.05, and you can see from this table here that all of the towns, with the exception of Dunedin, which as Sarah had pointed out, is quite different to the rest of the towns, it's all a lot higher. And so I just provided an indication in the column next to it, as if you apply that same ratio to work out what that daily guideline should be, if you were following their approach, just using the data for each of these individual towns, then it would suggest that the daily PM 2.5 guideline in each of those areas would be a lot higher than the 15 that the World Health Organization guidelines suggested. Now, I would just like to highlight that they do say in that guideline that they don't recommend that everyone develops their own guideline. They don't want us doing this, but the reason I'm trying to show you this is that it's less important. It's, in my view, the value is less, you get less, it's less significant to try and achieve that one than it is to try and achieve the 5, is the takeaway that I want you to get from this.
Emily, I've got a question here from Kevin.
Yeah.
You're based on that figure and what the WHO are trying to do, have we compared, so have we, say, grabbed Alexandra and found an equivalent geographically challenged spot on the other side of the world and see what's happening there? And if you know what I mean, like, where are they getting their figures from? And if there is a place, whether it's in France or England or whatever, what are they doing differently? What are their figures?
So a few years ago, I did do some work for the Ministry for the Environment, looking at sort of case studies in New Zealand versus overseas, air quality management in different sort of situations. I don't think that there's anywhere that you could or should be looking to. New Zealand is quite different in terms of there are other places where there are winter inversions and solid fuel burning as a contributor. We actually have probably more robust processes for managing it than what they do over there. Like, they don't seem to have a lot of the science inputs that we do in these small towns. Where it is a problem, quite often they will try an intervention without really having an understanding about what it's going to achieve, whereas we tend to take a more scientific approach here. We've got actually some of the best places in New Zealand. Nelson is a classic case in point if you want a good example of how to manage or how to, what sort of processes to undertake. We've probably got much better ones in New Zealand than what you will get overseas, and much more relevant to our situation. So to answer your question, looking overseas is not going to probably be a part of the solution for you, but there are some good places in New Zealand that you could look at. Nelson is actually an amazing.
Yes. So what you're really saying is that it's really important that we do shape it for the particular set of qualities that each of our spots have got.
Definitely should. Each is very different on not just from a science viewpoint, and not just from an air quality science viewpoint, but there's also other things that you probably will know about different districts in your region. Some of that information I've included in my report as well, but there's lots of considerations in there as well, like the variability in the cost of different heating fuels, different levels of insulation, different levels, different socio-economic sort of variables in there. There's quite a bit of information in my report as well on those things, including proportion of rental fleet versus non-rental, which have wood burners and which don't. So that sort of information will assist you. But it is, in my view, it is useful to consider all of those variables when you're considering your decision-making process.
Brian has a question, and then Elliot.
So what's so amazing about Nelson?
Nelson had an air quality problem in 2000. In 2001, Nelson had 81 breaches of the PM10 NES. So that's almost every day during the winter. They exceeded 50 micrograms. And they went through a process of evaluating science. So all the same sort of stuff as we've done here. We've done the emission inventories, we've done the science evaluations, done this management options assessment. And they took all the science and then they adopted what they thought would meet the air quality target. They had also communication strategies that went around it, and also behaviour change programs. So they got into the community and actually worked with the community as well to help them improve their air quality. And they got down from a really high level, and now they are compliant with the NES over a period of, so the air plan was notified in 2008, and they've been compliant with the NES in their worst air shed.
And there's learnings from Nelson for Otago.
Yes, there is particularly, yes, I believe so. I think there's learnings from Nelson for most places in New Zealand, but Otago, I think definitely, yeah.
Cool. Well, I hope we examine them. Thank you.
Yeah, I probably would also just add though, I mean, they do have a lot of frosts, but I think there are additional considerations for down here, like the temperature down here is, it is colder, so there are things, extra considerations that you probably need as well.
The really awesome opportunity with air quality is you can see change really quickly, as opposed to water where you've got a lag effect. If you make the changes in air quality, you see the difference. So it's a really good visible way that you can see what we're doing is making a difference.
So just wanted to I guess test my assumption here that the reason there is so much variation in the days and so the reason why that daily calculation isn't as useful as it might be in other places is because of that seasonality, because of that makeup being mostly winter burning.
It's in part that, and it's also the impact of meteorology. So we have quite variable, like you can even see if you plot like the 5 worst days, there's quite often quite a big difference in concentration between them. And so the meteorology that results in your worst case concentration is quite sort of specific and conducive, and similarly for your second highest concentration. And that, as we talked about before, can also vary from year to year. So yeah, it's to do with that sort of meteorology stuff as well as the variability and emission with the high winter density.
Right, and so since Dunedin might not be seeing those geographical factors and the makeup is a bit more evenly spread, is that why that ratio is a lot closer to what who might be expecting for
mostly I would say largely meteorology, yeah. And topography comes into it, obviously. Meteorology and topography, yeah. They sort of work together. So just a quick overview of the air quality targets that I evaluated in the report. These were basically the WHO guidelines and the proposed NES for PM 2.5, and then for PM10, the current NES with the WHO guidelines, and for the annual, the anti-air quality guideline, which was the 20 that Sarah showed on the graph earlier, as well as the World Health Organization 15. So there were four contaminants, two contaminants, and then for each contaminant, 2 different averaging periods. So to work out the magnitude of the problem, I needed to be able to account for the impact of meteorology that we've just talked about. I mentioned on here the second highest and the 4th highest concentrations, and that's just because each guideline has one allowable aura for, in the case of the World Health Organization, they allow 3 exceedances. So there's a difference there. And so for the NESAC, which allows 1, then we need to calculate the reduction required based on the second highest concentration. Whereas for the World Health Organization, because they allow 3, then we need to calculate it based on the 4th highest concentration. And so essentially, because some of these towns have downward trends in them already, we need to find a way to work out which is the worst case year in terms of meteorology, and then work out what the reduction required is from that. And so this is just to give you an idea so this is using Arrowtown as an example, and the blue dots is the annual average, and then the red squares are is the highest or the worst case concentration, and then the green dot is the ratio of those two. So you can do that just to see which years were worst in terms of those highest concentrations relative to the mean. And the mean is used as an indicator to track that trend. And so we can see from there that the 2 worst case years for Arrowtown were 2017 and 2021. And they were a little bit similar, although 2017 was slightly worse. So essentially it's just estimating, it's just taking a current day concentration and then saying, but we need to adjust it upwards for this impact of meteorology, just to make sure that we don't underestimate the reduction required and end up in a situation where we're non-compliant when we thought we would be. And then this is just a big old table showing all those different variations of the different standards that we were looking at trying to achieve, or the different targets that we're looking at trying to achieve, and then working out what the percentage reduction in the emissions or in the concentrations that were required to get to achieve each of those targets. And really, we don't necessarily need to look at all of those. If we were going to focus in on the WHO 2025 guideline, for example, we can see that the worst case towns for achieving this is actually Alexandra and Cromwell. And they both require a 57% reduction in emissions to achieve that target. But then also just highlighting the point that I've been referring to about the ratio or the relationship between the annual and the daily. If you compare the reductions required to achieve the daily WHO standard of 15, it's significantly higher. So we're looking at 84% in Alexandra, 78% in Cromwell, and 76% in Arrowtown, and 74% in Milton. So it's indicating that significantly higher reductions would be required to achieve that WHO guideline, which we've already sort of established is not quite as important as the annual one in terms of health benefits anyway.
Gary has a question.
Sorry, yes, so using that then, that sea change you referred to in Nelson, how would that compare to what could potentially happen for, say, Alexandra or Clyde or those areas? Is that a comparator that's achievable, that differential in change?
It was yes and no. It's kind of a complicated question or a complicated answer. Yes, it was about a 76% reduction that was required, but that was in 2004 emissions concentrations, and so yes, it is the same sort of order of magnitude or less. But what's happened since then is that the pool of wood burner emissions the magnitude of wood burner emissions has decreased. So back in 2004, all the burners in Nelson were all old school burners. So you could achieve a much greater reduction because there was a bigger differential between them and a low emission, or what was introduced as a low emission standard then, which we've since sort of reduced that standard again as well. So effectively, yes, in terms of the number, or actually the number was higher then, but in terms of what it takes to achieve it, that's a kind of a moving feat, and it's kind of changed a bit.
Okay, cool, thank you.
So then moving on so I've talked about the health, and I've talked about the magnitude of the reductions that are required in the different areas, and you can see that each area is a little bit different, and it's possibly different, it will be different to what it was when you did the original assessment of the air plan 10, 12, many more years ago. And so some of those areas will have already improved the area quality, and so the reduction required now, it might have been that Arrowtown previously was worse than some of those other towns, but there've been greater improvements there, and so things have changed over time. So the point of this was to say, what is the situation now, and what needs to happen in each of these towns now if we were to move forward to try and improve air quality.
So both those places have grown markedly in
terms of their population,
yep,
yes.
And the number of houses.
Yes, and we've taken all of that. We've got that information, and we've taken that into account.
But the airshed itself hasn't been remodelled. Like if you extend it out further, we're still confident that the airshed area covered. If your airshed used to be that's used to be Cromwell, and Cromwell's got like that. I'm just testing.
Yeah, we have looked at the airshed boundaries, and we've compared those with the spatial plans of the TLAs, and yeah, so we've looked at. It only looks like at the moment Wanaka and Queenstown are actually not quite, they've grown outside their boundaries, but I think for Alexandra, Cromwell, they're all still pretty much in those same boundaries as well. So
okay, cool.
So in terms of, I'm sorry.
That just begs the question, how are we measuring the towns that are getting out of their boundaries. Wonderful in Queenstown.
I think the key bit with that is, we'll still be measuring in the same way that we do now, and then we measure in the worst part of the township. So we'd be measuring accumulation in the worst part of the township regardless of the overall boundary. But we'd also do interim, spatial studies to make sure that we're, you know, as we go forward, we're still, measuring the worst part of the township. So, I think Sarah delivered a couple of papers that are part of the wider material for this workshop, that outline how those studies occur, and I think I'm thinking pretty regularly, 7 to 10 years sort of a basis.
As part of the air plan review, we will re-gazette any airshed amendments that we need. So that part of that, this process is that work to make sure that we've got them where they need to be and make sure that they're spatially accurate in terms of picking up the challenges.
So in terms of the science behind assessing the different management options, it usually starts with the base year. So that typically relates to the year that the emission inventory has been done, because that's the year that we have solid information on what the different heating methods and what is being done by different households and other sources as well. And then we conduct status quo projections, which is what is predicted to happen in the absence of any other measures, which includes your existing air plan measures, but it also includes central government initiatives. And I talked before a little bit about the impact of vehicle technology on, too. So it integrates those sorts of variables into it as well. And so you do get projected improvements in motor vehicles, which are accounted for in the status quo projection. It integrates assumptions or information on natural background contributions. So in each of these areas, there'll be sources like marine aerosol and dust, which will have some contribution. Some of the central towns in particular will probably have quite low contributions of some of those sources, but of marine aerosol, but potentially dust can be a significant contributor. Well, not significant, small, but significant in terms of it needs to be accounted for if you're looking at effectiveness of options. It integrates the annual data is used to integrate the effect of meteorology on the annual concentration. Sorry, the monthly data is used to integrate that effect. And as I mentioned previously, the daily data, we tie it into a specific meteorological condition, which is the second highest or the fourth highest, depending on which standard we're looking at. So that the projection model is actually just for a particular type of meteorological condition, and it's the type of condition that you need to achieve the guideline. And so this is an example. So in the report that you will have that I've done, I've just given an example of what the two different outputs look like, rather than presenting all of the results, which you can go to the report for. This is just an example of how the annual projections are illustrated. And so with the annual ones, we can break them down. There's just one reading per year, and you can get an indication of it by source as well, just the nature of the way the projections are done. There's a couple of air quality targets that are on there. So you can see for the projection example for Arrowtown, this is for the annual PM 2.5. You can see that the existing concentrations are estimated to be below already the proposed NESAC, noting that that's probably outdated. And the guideline that's probably most relevant is the WHO 2021 of 5. And you can see that that's the black dot on there. And so for this combination of options, showing a combination of options that suggests that in Arrowtown that target could be achieved by, and it shows the year that it's estimated to be achieved by. So we have for each of the areas that were modelled, Dunedin wasn't modelled because there wasn't enough information to go into it. But for all the other towns that we've modelled and included in the report are Clyde, Cromwell, Arrowtown, Alexandra, Milton and Mosgiel. So for each of those areas, we can conduct these sorts of analyses. And so it gives you an idea of how effective different options might be and how far down they might go. And then also it gives you a temporal aspect, which is by which time and what time frame. And then similarly, the daily ones are also presented. These are presented differently because the analysis is different, and it's just a linear extrapolation from a start year, which is the year of the inventory, and then projected down. And so for Arrowtown, we can see, for example, we've projected on this one, it shows the status quo projection, which actually shows continual improvement in Arrowtown is predicted until around 2031, I think it is 2032 perhaps. And then at that point, it's tapered off and probably a slight increase in emissions from that point on, but very, very slight. And then it also shows the option of phasing out burners and from a particular year. It will also include the impact of introducing a low emission and ultra low emission burner criteria. Now, I probably should just say that the report that I've prepared has a whole range of options in there, and so the key ones include the behaviour change program that I talked about. It includes introducing a new emissions standard for wood burners, which is basically the what is now the best standard. It's called the ultra low emission burner standard. You've probably heard about that already. So it includes an introduction of that. It basically includes measures progressively. So then if I've assessed that standard doesn't meet a particular target, then I'll put another option on top of it, which might be phasing out burners that don't meet that standard. And then a behaviour change program on top of that, and then an additional regulation on top of that. And it's basically just testing each time when you add this next layer on, does it then meet the target? And so for each, it's just evaluating them right through to the worst case option, which would be a prohibition on all solid fuel burning. And that option is always just included in anywhere where the target isn't achieved through other measures. And that's just, I'm not suggesting that that's a measure that you should or need to consider. I'm just saying each measure is just evaluated relative until we get to a point where that target is met, so that you have information on what might or might not be required if meeting those targets was something that was an objective that you set. And so assessing each of these towns, this is just a simple summary of different options that I've talked about relative to whether they would achieve or are estimated to achieve that WHO 5 annual average. And as you recall back, that was a 57% reduction in Cromwell and Alexandra, and different levels of reductions in other towns. And you can just see it assesses. We go through and we assess that the status quo is not predicted that any of those towns will meet that level, just under the status quo, nor the status quo just with behaviour change. So each of those towns is still likely to be higher than that 5 microgram target. If we required the ULEB installations and behaviour change, again, actually Mosgiel in that instance then would likely meet that target. And then if we also phased out burners over time not meeting the ULEB, then we have Mosgiel and Milton and Arrowtown are all estimated to then be able to achieve that target. In addition, if a behaviour change program is layered on top of that, then potentially Clyde could meet that target, although that's sort of where it fits into the uncertain, so it may or may not. And then if for areas where there's a lot of increase in population or a lot of building that's going on, then sometimes an additional regulation where you prohibit a wood burner to be installed in a new dwelling is an option that could then cap that. It sort of stops that further degradation. And so I tested that to see if that on top of those existing regulations might work in Clyde and in Cromwell, and yeah, that looked to be effective, but still in Alexandra, it didn't look like that was going to be enough. And then for all of them, if you phased out solid fuel burners, obviously all of them would then be likely to meet that target. So that's the scientific evaluation of what the effectiveness of different measures would be in each of those areas. Is there any questions on that? Because that's quite a complex one. Yeah.
Yeah, that's really interesting. So you do the minimum, I assume. So for example, Arrowtown, where it's just the ultra low burner and phase out non-ultra low will get you where you need to be, yeah?
Mm.
And that's good. So you do the minimum for each one. Whereas Alexandra, whatever you can do on this table doesn't achieve the outcome. So isn't there another row, as you said, where you have to, you know, whereas removing, I'm going to get shot for this, but removing just all fire burners, as you say, would get a yes.
But that is actually the bottom row is actually removing all fires, and that's why I said, you know, like,
Oh, sorry,
Yeah,
I didn't move the screen.
yeah, sorry.
Okay, well, there you go.
Yeah, so yes, we have gone to the end for all of them.
Okay.
Yeah. It's, yeah.
Kevin's got a question and then.
Wait, go.
Yeah, so for all of these places, you've got the number of, to get those ratios, you must have the number of, you must know the number of fires that have got to be replaced.
Yes.
Yeah. Or a pretty good estimate. Yeah,
Yeah.
Cool. And so therefore, what, moving on to, and I had rolled my screen up, so I knew what Brian's answer was chasing. So do we just move Alexandra? Well, I'm just saying, because you know, if we're never going to meet if it's a legal responsibility of ours to ensure that we're moving stuff into a correct zone.
I don't know, do you mean move it physically to a different?
Yeah, well,
to
that's-
to a-
what's your answer? Yeah, what's your answer? Because you can't give me reliable electricity in Alexandra, and my wife's auntie and uncle would probably want heated up
Yeah.
there most of the winter, really.
Can I
Yeah.
jump in, because it's really a policy response here,
Yeah.
and that's a decision that you've got to make, because you've got to also got to have people warm. And so you've got to balance that out. And that would be where your section 32 would justify which decision you make. And so you might make a decision that will make Alex as good as we can, and it may not comply with the NESAC, but will satisfy some of our other well-beings in doing that. But for all of our other airsheds, we'll go for compliance. That's a governance decision for you to make in terms of what you might look to do. But the other thing you can do is some non-regulatory support in Alex, more targeted to potentially, I don't know, I'm not quite sure what else, you know, solutions Emily might have. But it's an active decision for you as governors in terms of what you want to do, whether you want to go as far as phasing out all burners in Alex, or you want somewhere that's not quite that extreme.
And I think to that end, there is some good information in the report that would assist you with that decision making. So for example, I have included figures in there on cost of electricity per kilowatt hour versus cost of wood, information on demographics. There's lots of considerations, and I've tried to incorporate as many of them into the report so that you've got good information when you come to that point of making decisions around that, that you can consider. Those communities individually, you know, what is happening in them in terms of, you know, the housing stock, is it good housing stock? And, you know, there's relatively low levels of underfloor insulation, for example, in a lot of those places. And so, as Anita said, you know, the benefits that you will get, the health benefits that you'll get from improving air quality are really high, but they won't be realised if they're at the expense of people going really cold. And so there is a balancing issue there for you to consider. And the other aspect of it is whether you get to consider it or not depends on what the NESAC looks like. And at this stage, the NESAC hasn't come out. And because you have this information in front of you, if it comes out in a consultative form and you get the option to provide comment on it, you can go and you can say, this is, if you introduce 5, this is what it will mean for us in Alex. And that is good information for you to share with the ministry so that they can understand the full extent of the problem as well.
Sweet, I've got a bit of a queue developing, so we've got Christian, Gary, Henry. Brian.
Probably got an obvious answer, but public would ask that we're absolutely sure that solid fuel burning is the cause of the issue, I guess. from the timing of the results, etc., I'm sure that's probably true, but we would have people saying, oh, it's industry, it's people who burn green waste on the peripheral, it's something else. So just making sure that we have considered all of the options to bring down those numbers.
Yeah, and so it's really the evidence for solid fuel burning is really comprehensive. But then what I would say is that is definitely the source of the wintertime problem, which is, you can see it in your data, but it's possible, Sarah referred to earlier about some other issues going on in Alexandra and in the non-winter months, and that's probably not going to be a solid fuel burning sort of issue. And so whilst you might, in many places in New Zealand, not many, but in a few places in New Zealand, we have this big issue with solid fuel burning that we're managing, but then there might be like a side issue of something else that's happening during the non-winter months. Sometimes it's outdoor burning, sometimes it's just one particular industry that is causing a problem, sometimes it's dust or sea salt. And so just getting an understanding of what's happening and making sure that those little potential extra sources like the outdoor burning can be a contributing factor, and just making sure in areas where outdoor burning has the potential to be contributing that we get rid of that little signal, so that what we do that targets people and lives is most effective. Yeah.
Thank you very much, Gary.
Well, thanks. From what I see for the likes of Alexandra, I don't think outdoor burning is the problem at all. It's quite interesting that we've ruled out behaviour change, but I've got a firewood supplier who leases some land off me, and I can see the problems immediately, having watched how they function. I see the other ones that are local as well. The behaviour change, in my mind, this council could quite easily fix that. But it's curious really that it's ruled out here. For Alexandra, the cost element of it is possibly almost a lesser extent. It's the unreliability element when it comes to power being unreliable. It's so cold that the risk of not having power means potentially for a lot of people only have electricity, they have no heating. But there are things that can be done from a behavioural change. Certainly with how firewood suppliers, they're under-resourced, the timing, and then when people run out because they never order enough, and then the only wood that's left in late July, August is wet wood that hasn't been able to be provided, but they're out. So that gets delivered and used, and it's making those changes would be a big step forward towards a parameter that the town will never meet, full stop. Sorry, that's not really a question, it's more of a statement.
Yeah, and can I just because there might be a couple of little things, the Nelson example that we referred to, they have as a part of their sort of behaviour change program is a good wood supplier kind of certification, and then publicity around you buy your wood from a good wood supplier. It's probably harder in a smaller town where there's probably only a limited number of suppliers, but again, it's working with the community. So the council was working with the wood suppliers to fix that problem, and there are definitely ways and mechanisms available. One of the recommendations that I have made in the management options report as well is that there are uncertainties in the analysis because of things that we don't know, and so there is always this potential to layer, to have a sort of iterative approach to it. And because something like behaviour change, what it will achieve will vary a lot depending on where you are and what is going on already. It is quite a hard program to implement effectively because it's not just education, pamphlets and everything is just not going to achieve what a behaviour change program needs to, it needs to be targeted, it needs to be really well thought through, including quite a psychological sort of aspect of how do you actually get people to change their behaviours, how do you get into their homes to talk to them in a positive way about what they're doing with their wood burners. It's quite a comprehensive thing. It's not small, but it is something that can be quite effective, so it's definitely something worth considering.
And can I just say that you'll recall that we're doing the air plan review and the air strategy as in tandem, and so we've got the strategy team sitting in the corner, and that'll be part of what goes into the strategy, which the plan will just be one part of the year strategy. So all those options will be put forward, and that they've all got different costs and benefits, but you'll see all of that when we bring both those packages together next year at some point.
Sweet, we have about 10 minutes left, 2 questions and 1 slide, so Elliot, you're next.
Okay, try to be quick. Sorry. So just I've been thrown off of the strategy and plan. Is the plan will be within the strategy as one piece of the strategy, and then the like non-reg stuff will be the other side of that. On our climate strategy that was just passed yesterday, some steps of one of the things that were approved is a review of energy resilience around the region. And I think even with particular regard to how that relates to winter burning, I'm just wondering if we know what sort of timeframes we're looking at with that, and when we have that information, if we might be able to review the air plan measures once we have that sort of relevant information.
Short answer is no, not yet, but because it's the same teams, we'll be able to factor that in.
Sorry, I was talking to see you're sorted. Andrew, then Alan.
2 questions about low emission burners. Are you able to indicate approximate price differential and whether the low emission burners are designed to burn overnight?
The ultra low emission burners. So that's, I think ultra low emission burners is the best technology. Is that's what you, yeah. So in terms of price differential, the last assessment was done as basically the prices come down to be equivalent, so that they're considered to have no price differential anymore. When they first came out, there was quite a significant one, but obviously as you get more players in the market and more sort of competition, and then also they managed to get them more cost effective. That's not all of them, obviously, there's still quite a range. And in terms of the second part of the question was,
Will they burn overnight?
yes, some of them can do an overnight burn, and that is because of the technology that has been adopted. So there is a few that have been adopted with catalytic converters, which means that it's like secondary technology that actually does the emission reduction. So some of those do. The majority of them probably don't. Of the ultra low emission burners, the current any sort of current burner that meets the NESAQ design criteria, or that sort of next level up, shouldn't really be able to burn overnight. But some of the ultra low emission burner ones actually can.
I think you just get up at 1 o'clock.
Yeah.
3 o'clock.
We had
You go to the doctor.
Alan.
Can't see.
Brian, oh, sorry.
Oh, sorry, Brian, I've got you.
So phase out solid fuel burners, a reply was, oh no, we can't do that because we don't have electrical resilience. But if that should be phase out solid fuel burners / resolve electrical resilience issues. So for example, to go to Alexandra and say, well, fundamentally, what are the issues? What's it going to cost to address these issues, whether it's distribution, whether it's supply, or whether it's an alternate arrangement. You've got a river there, you could have heat pump situations with the community. Anyway, I'm just saying something in tandem as opposed to ruling it out. What would be the cost to address the lack of resilience?
I guess at this point, this is just a science evaluation of what the effectiveness of options. I think there's probably more considerations in there. The electricity resilience is probably a consideration, but there's probably, as you go through the process of evaluating it, you might find that there's other things in there that you want to consider as well.
But all I'm saying is to look at those at some point. Yeah.
And that's what the strategy will do. So again, the air plan is just one of the tools that the strategy will engage, and there'll be other tools. So Blair and I came up with just a handful of ideas while we were thinking about, we think about Nordic countries that are as cold as Clyde, and they have heat pumps that work. So there's all sorts of things you might want to, I don't know, invest in solar panels in people's houses so they've got some more resilience, or do some kind of other energy transfer system. I don't know. I mean, I lived in Clyde, I know it's cold. But there's a whole lot of things, and all of those will be explored and packaged up and brought to the table.
solar and not. wind.
It's awesome. We have Alan and then Kate.
Thanks. Look, we've been mostly talking about particulate matter, of course that's important, but I guess I'm wanting to go back to nitrous dioxide. And we've heard those provisos around the science understanding for health effects and that over time it's predicted with the changes in the vehicle fleet. But I think my question is, you know, we do know from the modelling that particularly through that HAPPEN study, that there are serious health effects from nitrous dioxide, particularly in Dunedin, especially in Dunedin, where that's one of the worst rates in the country. I guess at what point, in thinking about how this informs that air strategy, at what point is it reasonable to say, look, the modelling shows there's really bad effects here. We don't need to wait for more monitoring. The modelling is clear, let's get on with it. Is that and I'm not sure on with what, but is that a reasonable position to say, we know this is a problem?
I guess there's probably two things that I would say. I would say, first of all, I would want to monitor because that model network that happens was based on, was a model. It is based on 120 2 passive samplers across the country. It's probably not a lot for the whole country, but they developed a model based on it. And those passive samplers are they don't meet the requirements that the NES would of a standard that they're less accurate. So I would say, first of all, I would say, no, I would personally monitor, I wouldn't rely on that. And then secondly, I would say, probably just worth considering as well what tools you as a council have available to you to deal with NO2 anyway, which is not a lot. So I would just qualify with that, I guess.
Okay, thanks.
Also, we have Kate.
I'm going to Brian's point, but understanding how you can solve when you do this. I mean, it's fine for us to all come up with ideas and not having lived in those areas where it may be fog for a week and then and we've all tried heat pumps that are meant to work at below -5, and I can tell you that they don't. But there's also that visual thing about fire, which is innately, as Tim has said in the past, innately comforting. And so I think there's a whole lot of other psychological things we have to be really clear about when we try and do this. And it's, while we're almost pigeonholing air as the only thing, when we have to look at a much wider, the balance and that cost benefit analysis. I'd love to know how many people die of cold related, not eating. And every time we get an electrical shortage in New Zealand, we hear stories of people turning off the electricity, and it's not a good look either. So we just need to balance some of that stuff, and I hope we're not just pigeonholing the science of air in order to drive a.
I mean, we've only just started looking at this, but I can't imagine that we would be recommending, and I don't want to predetermine what James and the team is going to do, but I can't imagine we're going to be saying you must improve air quality at the cost of being warm. Because I've lived there and I know heat pumps don't work, and we had a 2 or 3 week conversion there, it couldn't get above -2, and you don't see the sun, so solar panels will count, all of that stuff. So there is definitely a balance in here, but that doesn't mean we shouldn't work to make it as good as possible, even if we can't get across the line everywhere. So that is that's a policy discussion, and it's a governance decision, and it is looking at the whole package of things. So it's not equality at the cost of everything else.
And I get, sorry, is that the last slide?
Can you carry on? Yeah, I was just saying you carry.
I was going to say, it kind of leads into the last slide in a way as well, because this is being presented from the perspective of, there are different sort of options that you can choose in terms of how you approach this. And so what you can see in this table here is 4 options across the top, and then just 4 different, which are option 1 to 4, and then A, B, C, D, which is different ways of sort of categorizing the towns. And so then the first option is, well, if your objective and what you were trying to achieve was just compliance, was absolute compliance with WHO and the monitored air sheds, then this is what the science is telling us is the suite of options that would be effective in, or likely be effective in achieving that. But if you were looking at other objectives, then there are other options and other classifications there. And so it might be that we can see there that the second option is likely compliance with WHO and all their sheds except for Alexandra, which is potentially would come within 1 microgram of that limit, and improvements in other towns as well. So that's adding in how to get improvements in some other towns that we haven't been able to include in the modelling. And then as we go across again, it's just progressively changing or saying, well, we might not achieve compliance in these areas, but we could try these measures and see how effective they are. And there is additional stuff that you could do as well. If you wanted further information to help you with that, you could look at what is the health cost of us, just from an air quality point of view. We don't have a model that will help us with the cold homes sort of side of it to balance. But from an air quality point of view, we could say, well, what is the cost, or what is that health cost of, not of it being 1 microgram higher in Arrowtown, or, or up to 2 micrograms higher if we went with this other option, which is going to be a lot easier for households to achieve. So it's giving you just direction on how you could look at it from a science viewpoint, and what the likely outcomes would be for different sort of combinations of measures in different areas.
Very awesome.
As someone who lives in an 1880 house and thankfully not registered for historic places, can I just make sure that when you're starting conversations with Heritage New Zealand and TAs, that they don't have stupid rules that preclude good things going in to replace old chimneys? They become really, really hard in that space.
Noted.
Do we have any other questions? Kevin, is your?
Oh, yeah, just a quick one. I'm really interested in this NO2 one, because if we just say, well, let's continue monitoring, I don't think any monitoring is actually going to change the fact of 101 deaths in Otago. So we're probably at a stage where we actually got to start looking at actions. We've definitely got to keep building up monitoring without any worry, but it's, I think we're past that. I mean, we've got the facts and the numbers, so we probably really got to look at some actions. And then if you have a look quickly, you've said about that we are looking at doing in the LTB, we have NO2 monitoring, which is a new thing and has pretty bad results. But in Oamaru on page 18, you have where we're a big red mark for our mean PM 2.5, where we're not going there to do the monitoring. So we already know that that's there, and I would hate to think that we're doing something there quite dramatically quick, because it shows up on the map as quite dramatically bad.
Yeah, because we've got so many air sheds, we've sort of started going through a process of we need to figure out where in the air shed is the worst, and so we've got a process that we're doing that.
Yeah.
And then after that, we can hopefully implement some sort of temporary monitoring at some of these places, and then get a better idea of where we need further monitoring from that. But it's because there's so many air sheds, it's such a long process. But definitely Oamaru is next on the list, based on monitoring we've done last year.
Yeah, and look, I'll only put that around in that you know that is bad, yet we're going to put gear into Frankton. And I'm not against putting gear into Frankton, but you're putting gear into Frankton to prove whether it is good or bad when you've already got one that should be that we should be doing some action on. So yeah.
Oamaru would still come within potentially one of these scenarios, even though we haven't modelled it. We'd still be able to apply one of these management scenarios to somewhere like Oamaru, and then we'd be able to pick up the improvements that we made with the ongoing monitoring. So just because there's not a monitoring site doesn't mean we wouldn't implement a management scenario for those other towns. There's other parts of the region as well that will be similar to Oamaru. Balclutha is as an example where we had some monitoring and we stopped, but we know that there's air quality issues, so. There'll be a policy decision for you about how widely you apply these scenarios and whether you take a different approach to some areas versus others, and or apply some of these scenarios to areas like Owamuru or Galtufa.
Yeah, and I'll just go, quickly, I will cut, but this is actually important, and I'll go back to what Gretchen said earlier, that if we do try and implement any actions or put something forward, it's really critical that we've actually got the figures there to do it. So, and prove that that is the cause. So, yeah, no, that's good. Thank you.
10 seconds for Andrew.
Emily, with your experience around the country and the various other councils that we work with to develop management interventions, would it be fair to say that those councils have considered the four well-beings, i.e. environmental, economic, cultural and social aspects when they develop those management interventions?
Can I just maybe start, because there's going to be a difference between your considerations for your strategy versus your plan. So your air plan considerations are guided by the RMA, your air strategy considerations are more guided by the LGA. So you can take a slightly different and more nuanced approach to one versus the other. So, the RMA governs how you think about what you're doing and how it achieves it. And the LGA is sort of focus.
Thanks, Anita. We're going to wrap it up, because we've got another meeting starting in 5 minutes. So thanks very much. It was a really engaged discussion. It's been on a bit of a roller coaster. We've had the background and gone right through to getting some ways forward, which is some options to think about. So thank you very much. It's been an awesome workshop, and we'll just close it off now. And we won't do a karakia right now because it's the same committee that's going forward to the next meeting. So we'll come back at 12 minutes past 11. So we got ready for the meeting to start at 11:15 for the committee of the Program Science and Policy. So thank you very much, Sarah and Emily. It was awesome. Well done. Thank you.